So let's turn our attention now to dietary fat intake. Again, information from this joint position statement published by the American College of Sports Medicine and the American Dietetic Association and the Dietitians of Canada. They recommend that dietary fat intake by athletes should be in accordance with public health guidelines. So that is 20 to 35% of total energy intake should come from dietary fats, with less than 10% of total energy intake coming from saturated fats. So they also recommend that dietary fat intake should be individualized based upon an athlete's training level and body composition goals. So certain athletes may choose to excessively restrict their fat intake in an effort to lose body weight or improve their body composition. However, it's recommended that dietary fat intakes not be lower than 20% of dietary energy intake, as this may reduce the intake of a variety of important nutrients, such as fat-soluble vitamins and essential fatty acids. So more information from this joint position statement. They state that claims that high-fat, carbohydrate-restricted diets provide a benefit to the performance of competitive athletes are not fully supported by the current literature. So this joint position statement was published back in 2016. So let's look at some more recent evidence looking at the impact of a low-carbohydrate diet, a low-carbohydrate, high-fat diet, on athletic performance. So this study, also published in 2016, they looked at metabolic characteristics of keto-adapted ultra-endurance runners. So you can see the information about these runners here. They were all elite ultramarathoners and Ironman distance triathletes. Of the 20 athletes, 10 of them were following a ketogenic diet on their own for an average of 20 months with a range of 9 to 36 months in duration, whereas the other half were following a traditional high carbohydrate diet that you see there, HC. Now, athletes adapt to dietary changes in carbohydrate intake. And though athletes regularly consume carbohydrates and use them as a primary source of energy during aerobic exercise, consistent intake of a low carbohydrate diet leads to a greater reliance on fat as a fuel source. And we'll see some evidence of that here in the upcoming slides from this study. So if we look at the habitual daily nutrient intake of the high carbohydrate and the low carbohydrate groups, if we look at the protein intake, it's very similar in terms of relative grams per kilo per day. If we look at the percent of energy provided by carbohydrates, about 60% in the high carb group and only about 10% in the low carbohydrate athletes. And they're replacing the carbohydrates with fat primarily. So if we look at the percent of energy as fat, about 25% in the high carb group and upwards of about 70% in the low carbohydrate diet group. So looking at the experimental design here, what you can see is this was basically a 2-day study period. So on the first day, they performed the VO2 max test. They then came back to the lab the very next morning, had their body composition assessed via DEXA. They then had a muscle biopsy performed of their vastus lateralis. A blood draw was performed. And then throughout the day, they had multiple metabolic cart measurements to look at fuel utilization both at rest as well as during exercise. So here at this point, as well as following exercise, they consumed a shake that was similar in nutrient composition to their habitual diet. So you can see the breakdown here for carbs, fats, and protein for the high carb and the low carb athletes. And then at 9 a.m., the athletes jumped on the treadmill and ran continuously for 3 hours at a moderate intensity, about 65% of their VO2 max. After that 3-hour run, during which blood was taken at regular intervals, they then sat down and for the next 2 hours were allowed to recover. You can see the muscle biopsies here taking pre-exercise, immediately post-exercise, and then 2 hours later after that 2-hour recovery period. So using the metabolic cart, they could estimate fuel utilization both at rest as well as during exercise. So looking at their resting respiratory exchange ratio, which gives us an estimate of the type of fuel that's being used during that specific activity. In the high carb athletes, their resting RER was on average 0.86, suggesting that about 47% of energy is coming from fat and about 56% of energy coming from fat during a 3-hour exercise bout. Now, if we look at the low carbohydrate group, they had a much lower, significantly lower resting respiratory exchange ratio, suggesting that upwards of 95% of their energy is coming from fats at rest, and during that 3-hour treadmill bout, still a very high rate of fat as a fuel source during submaximal exercise. So if we look here at carbohydrate oxidation, again coming from the metabolic cart data, at baseline, this is all pre-exercise here, and then the 3-hour treadmill run, and then the 2-hour recovery. We see here in the high carb athletes a greater utilization or reliance on carbohydrates, both at rest as well as during the treadmill run. And if we look at the low carb athletes, a much lower reliance on carbohydrates as a fuel source, both at rest as well as during exercise. Now if we look at fat oxidation, we see here comparing the high carb and the low carb athletes again. In the low carb athletes, both at rest as well as particularly during the 3-hour treadmill run, a much greater reliance on fats as a fuel source to fuel exercise. And then we see here with the high carb athletes, they see a significantly lower reliance on fats as a fuel source during exercise. So overall, what we would normally see in a person who's consuming a traditional high carbohydrate diet is that during exercise we see a reliance on carbohydrates as the primary fuel source, but over time during prolonged exercise a steady decline in carbohydrate oxidation, suggesting a decreasing reliance on carbs as a substrate during prolonged exercise. And then those same high carb athletes, this is what we would expect to see during prolonged exercise, is a gradual increasing reliance on fats as a substrate during prolonged exercise in the high carb group. So overall, what they found was that highly trained ultra endurance athletes adapted to a low carbohydrate, high fat diet, and this was shown by significantly greater rates of fat oxidation during exercise. So overall, this suggests a greater capacity to utilize fat as an energy source. And this was in comparison to similar ultra-endurance athletes consuming a traditional high carbohydrate diet. They looked at muscle glycogen from muscle biopsy samples. And surprisingly, they found that muscle glycogen levels were similar between groups pre-exercise. So what you see here is at baseline, very similar muscle glycogen levels in the high carb and the low carb athletes. The investigators speculated that this similar muscle glycogen content pre-exercise was a result of a number of chronic metabolic adaptations to the low carb diet. They also looked at muscle glycogen levels immediately post the 3 hours of running and then 2 hours later during recovery. And overall what they found is that muscle glycogen utilization during exercise as well as resynthesis patterns were similar between the diet groups. This figure here just showing the individual subject changes in the high carb and the low carb athletes. We see that each and every one of the athletes had a sharp decrease in their muscle glycogen content as a result of performing 3 hours of prolonged exercise. And then each and every one of the athletes had a rebound or resynthesis of muscle glycogen during the 2-hour recovery period. For those who are interested, this is a link to a YouTube video of the primary investigator or the first author of this paper, Jeff Volek. speaking about this study in more detail and its relevance to athletic performance. So overall, in this study, what they concluded was that long-term consumption of a very low carbohydrate, high-fat diet in highly trained ultra-endurance athletes resulted in a number of metabolic adaptations. These adaptations include enhanced ability to oxidize or metabolize fat during exercise, as well as maintenance of normal muscle glycogen concentrations in the context of limited dietary carbohydrate intake. So from a practical standpoint, these observations broaden the dietary options available for aerobic athletes to include a very low level of dietary carbohydrate. So they concluded overall that consuming a chronic, very low carbohydrate, high fat diet, or undergoing what is known as keto adaptation, broadens the dietary options and provides an alternative to the supremacy of the high carbohydrate paradigm for endurance athletes.